Welcome back to Robominions.in AI interview preparation app. The topic of this video is double hashing to resolve collision. Before tracing the code, I request you to watch this video on your laptop or a full-size screen on your mobile phone in a horizontal view so that you can clearly trace the code along with me. If the code is not clearly visible on your mobile phone, I strongly suggest you to watch this video on your laptop. The app I'm using to trace the code is Robominions.in AI interview preparation app. To download the app, you have to visit the website robominions.in. Download the latest version here and click on download for latest version. And if you have Windows OS laptop, click for download for Windows OS and then click on download anyway. The app gives you an option to click back and next in the code, and you can trace the code so that it helps in the revision and for preparation. Okay, now let's start tracing the code, double hashing to resolve collision. This arrow will go to the exact code line execution. It helps in tracing. Right now it is pointing at hash include stdi.h, and we are following this convention: data, index and address of the specific array member. Okay, so then we have hash define. Hash size is 10. Then we are having a prime number which is 11. It's also a macro with a prime. Then we have int hash table, a global array which is initialized with value 0. So it has a 0 to 9 index. Then we have hash int key, and then we have prime underscore hashing with int key. So we have prime hashing is available here. You can see here it's available here, and hash is available here. Okay, now let's go to the void main. In the void main we have int data underscore array with values 7, 14, 52, 57 and 105. We have int location declared, and then n is equal to 5, the size of the array. Then we have a for loop which will start from 0 till 4 and go through each data values and add it to the and insert it to the hash table. So we now have insert in bracket data underscore array of I is 0 right now. So I 0, for 0th value we have 7. So insert of 7. Then we have int index equal to hash of key. Key is 7 right now. So hash of key. So we return key mod hash underscore size, that is 7 mod 10, which is equal to 7. So return 7. Then we have hash table of index is 7. So hash table of 7 is 0. So 0 not equal to 0 is false. So it goes to the next line. Here we have hash table of 7. Hash table of 7 equal to key. Key is also 7. So 7 has been added. End of the insert function. Then we increment I. Now I is 1. Now again we do a insert of data underscore array of 1. So data underscore array of 1 is 14. So insert of 14. Int index equal to hash of key. So hash of 14. Then we return 14 mod 10. That is 14 mod 10 is 4. So index equal to 4. Then we have hash table of index, that is hash table of 4 is 0. 0 not equal to 0 is false. Then hash table of index 4 equal to key value 14. So 14 is added to the hash table. End of the insert function. Then now I is incremented to 2. Again we call the insert function with the data array of 2, that is 52 is key now. So insert of key 52. So we calculate the index from the hash function. So we return 52 mod 10 equal to 2. So now index equal to 2. We have a hash table of 2 is 0. So 0 not equal to 0 is false. So now we add hash table of 2 equal to 52. The key 52 has been added. End of the insert function. Now I is incremented to 3. So now we have 57 now. So let's see. So 57 is the 3 for I equal to 3 we have for third index we have 57. So 57 we calculate the hash now. So 57 mod 10 is 7. Now index equal to 7. Now we have if hash table of 7 hash the index is 7, right? So hash table of 7 is 7. So 7 is not equal to 0 is true. So we have to perform a double hashing. Now we have seen a collision here, right? So we can't insert 57. So we tried inserting, the hash value was 7. So at the index was 7. So at the 7th index we have faced a collision. Now we do a double hashing now. So we pass the key 57. Again calculate the hash value. So it returns 7 now. 57 mod 10 is 7. I equal to 0. Then we have a while loop. Here we have hash table of hash of index. So hash of index 7 will be again 7. So it goes to 7 mod 10 is 7. And then we have I is right now 0. 0 into prime hashing. So prime hashing is calculated. So it returns prime 11 minus key 57 mod prime. So 57 mod 11. So 11 minus 57 mod 11. So 57 mod 11 is 2 because 11 5s are 55. Remainder is 2. So 11 minus 2 is 9. So 9 is returned. But as it is I is 0. So 0 into 9 will be 0. Hash of 7 is 7. So hash table of 7 is 7. 7 not equal to 0 is true. So it goes inside. I is incremented to 1 now. So now we do again the value calculated. The index has to be calculated. First we go to the hash index. So again we find key mod. So we have index equal to 7, right? So key mod hash size, that is 7 mod 10 is 7. Then we have a hash table of 7 plus I is 1. So 1 into, first we calculate the prime hashing, this part. 11 minus 57 mod 11 is 9. So 1 into 9. So 7 plus 9 is 15. 15 mod 10, sorry, 7 plus 9 is 16. 16 mod 10 is 6. So at 6th location it is 0. So 0 not equal to 0 is false. So we come out of the while condition and return the value 6. So at 6th location we have 0, right? So we return the 6. Again we calculate the prime 9. So we have index 7 plus I is 1. 1 into 9. So 7 plus 9 is 16. 16 mod 10 is 6. So we return the 6. So we have index equal to 6 here. And then we have hash table of index, that is hash table of 6 equal to key is 57. So hash table of 6 is 57 has been added to the hash table. End of the insert function. Now we try to insert 105. So we have incremented I to 4. So insert 105. Int index equal to hash of key. So 105 mod 10 is, it returns remainder 5. So 5 index equal to 5. Then hash table of 5 is 0. 0 not equal to 0 is false. So it easily adds 105 to the 5th index. So 105 has been added. So returns from the insert function. I is incremented to 5. 5 less than 5 is false. So now we have successfully added the data to the hash table and also resolved the collision. Now let's try finding the 57 location. So search 57 is called. So we go to the search 57. Key is 57 here. We have int index equal to hash key. So we calculate the key, that is 57 mod 10 equal to, sorry, we calculate the hash. So 57 mod 10 is 7. 7 is the index. I equal to 0. Then again we have while hash table of hash index will be calculated. 7 is written. 7 plus I is right now 0. 0 into prime hashing value, which is returned as 11 minus 57 mod 11, that is 9. 9 is written. So hash table of 7 plus 0 is 7. So at 7th we have faced a collision. So 7, sorry, not a collision, but a different value. 7 is not equal to 57 is true. So we increment I inside the while loop, and we find if a hash table of again we calculate the hash value here. We are checking whether there is a valid value after incrementing I. So 7 plus 1 into 9. So 7 plus 16 mod 10. So hash table of 6th position. So 6th position we have 57. 57 equal to 0 is false. So it doesn't return -1. So it doesn't go inside the if condition. It has turned false. Now it goes back to the while. Here we have hash table of, again we calculate the hash index. Right now I has been incremented to 1. So keep that in mind. Now 7 plus prime hashing returns. So we have 7 plus I is 1. So 1 into 9, that is 7 plus 9 is 16. 16 mod 10 is 6. So hash table of 6 is 57. 57 not equal to key. Key is 57. So 57 not equal to 57 is false. So comes out of the while, and then we return the search location. We calculate the index again and return the search location. So we have 7 mod 7. So hash index is now 7, and we calculate the prime hashing now. So prime hashing is 11 minus 57 mod 11, that is 9. So 7 plus 1 into I was 1, right? So 7 plus 1, that is 7 plus 1 into 9, which is 16 mod 10 is 6. So we return 6. 6 is the location we were looking for. So at 6th position we have found the data 57. We return from the void function. The order of the time complexity is actually order of 1. If we don't face any collision, if we face multiple number of collisions, then the order of time complexity would have been the order of k, where k is the number of collisions to search the element we are looking for. Okay. For insertion, again it also depends on the number of collisions. So it will be order of k. So if there are no collisions at all, then it would have been order of 1. Okay. So that is the best case. To trace the code, just like I have done, you can use the app Robominions.in AI interview preparation app. The code is available in the app. You can click on the code button. By clicking back and next button, you control the code, and you can trace the code line by line. It helps in it really helps in revision. Just before going to an exam or interview, you can quickly revise all the concepts. The app is available in the website robominions.in. Click on download for latest version, and then click on download for Windows OS if you have a Windows laptop, and then download anyway. Click on download anyway. Okay. See you guys in next video. Thank you. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.